Greetings. Well, in this video today, we're going to be looking at Chapter 7 in the Van der Waal Elementary and Middle School Mathematics textbook, looking at notions of counting and early number sense, kind of where a lot of things begin in the school sequence. So in this video, we're going to look at some various types of skills related to counting, and review a learning trajectory for counting, and then unpack this idea of number sense and what that entails, and look at a few different number sense activities to get a better idea of what that means in the classroom. So let's start with counting. Well, when we think about counting, counting sheep in this case, 1, 2, 3, 4, 5, there's actually different skills that are required to do what I just did successfully, even counting those sheep. Let's think about that. Well, the first thing is we have to know these names that I just put out there without much thinking. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have this oral counting sequence of the words we use to express number. And that's the first thing we need to do to be able to count. Because if we don't know that sequence, well, we aren't going to be able to count. So that's the first step. The second thing is, as we count those sheep, I need to be able to attach one of those number names with one of those sheep. And often when you see young learners start to count, they may, for example, count too fast. And as they're looking at those sheep, they may say 1, 2, 3, 4, 5, 6, 7. And it's because they weren't able to attach one number name with one sheep. Or you might see them make other errors about counting something more than once and counting in circles and touching the sheep 1, 2, 3, 4, 5, 6, 7, and they just recount some of the sheep. So it's important to know that each object gets counted once and to have the skill of attaching one number name to one object being counted. And lastly, there's a special skill knowing the last number we say actually represents the whole set and not just that sheep. Now, it's interesting with younger learners, before this skill is acquired, an example of someone who doesn't have that skill yet, they may count the sheep and say 1, 2, 3, 4, 5. And then you say, great, so how many sheep are there? And they may look at you funny and say 1, 2, 3, 4, 5. And like they just told you, and you say, well, how many sheep are there? And I just told you 1, 2, 3, 4, 5. And the reason that that's happening is because there is a little bit of developmental skill knowing the last number you say. When I say 5, it doesn't just mean that fifth sheep. It actually represents the total number of sheep altogether. There's something special about that last number that we say. And that's something that was termed the cardinality principle. And the cardinality principle just says that it's a developmental skill. The last number said represents the entire set. It's not like something that has to be taught specifically, but as children get experience and see modeling by others, it's something that a skill that gets developed over time. So we're going to talk more about counting here, but for a minute, I encourage you to pause the video and read through these 6 situations and try and think about what are some similarities and differences between the counting occurring in these 6 situations. So pause the video and give it a quick read. All right. Well, when we think about counting skills, I want to give a nod to a professor and researcher, Arthur Baruti, who is a longtime researcher at the University of Illinois and is still an emeritus professor on campus doing research with young learners in math education. And this is one of his publications, which is trying to break down the notion of some of the skills required in counting. And when we look at this graphic organized here, I want to go ahead and circle in on 4 of these that actually represents the 4 different types of counting skills that he looked at in his research. And starting from the left there, it starts with the idea of oral counting, which is what I just said, just being able to count the number sequence, no objects even present, but just being able to count out loud 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And just being able to count the sequence correctly without any regard to actually attaching it to any quantity. Well, then as we do start attaching it to quantity, think about counting a set of blocks or something like that, and being able to determine the number of items in it. We look at the next one over, which he used the term enumeration. Van der Waal calls it a counter. But the idea here is being able to have that one-to-one correspondence, and if let's say there's a little pile of blocks in front of me, and I can count 1, 2, 3, 4, 5, 6, and know that I did the one-to-one counting correctly. I stop on the last one, and then I have that cardinality principle to know that the 6 means the whole set. That was what we can term as typical, being a counter, being an enumerator. On the right to that, a little different one is called set production. And this is different because now imagine a large pile of blocks. And I told the student, can you count out 6 for me? And the student has to be able to go to that large pile of blocks, count out 6 items, and know to stop, and know that they have produced that smaller set of 6 from a larger set. And that's a different skill. When you think about it, one major different thing is they're starting with the end in mind. They have that 6 in their head, and now they have to go to a large pile of blocks, remember that 6, being able to use that one-to-one correspondence and be able to stop when they reach 6 and know that that smaller set was their goal. And that's deemed set production, or Van de Waal calls it a producer. And lastly, he in his research talked about the notion of comparing quantities and being able to determine whether, if you have 2 or more collections, if one is greater than the other or less than or equal to go through. This is kind of a different notion of counting. Not just being able to get a number, but know if that number is greater than, than another number. And some of that just refers to the idea that students have to make the connection that, once you have numbers that occur later in the counting sequence, like 9, that automatically is greater than 6, which occurs earlier. And this also is something that comes with practice and experience and development. Now, with that, if we go back to the 6 scenarios you looked at, we could ask, well, where are those 4 skills of counting represent here? So the first one, for example, Tiana counts the number of children at a table to determine the number of children present, would be an example of enumeration. Because there's a set number of children, she counts around, she reaches the end, she stops, and that would be enumeration. The second one, however, says because there are 7 children at a table, Tiana counts out 7 pieces of drawing paper from the stack of papers she is carrying. Here we have a large set of paper, and she has to keep 7 in her head and count out 7. That'd be an example of set production. Third, Deshawn is chosen as it for a game of hide and go seek and counts out loud to 20 while the other children hide. Again, this is an example of his oral counting. He's not actually counting any objects, but just knowing the number sequence and being able to do that correctly out loud or in his head. Number 4 would be an example of that number comparison, being able to know that 5 is more than 4 as in terms of counting sequence goes. Number 5, Brandon rolls a dice and counts the 6 dots. Well, there are only 6 dots, so if he counts each one, that'd be an example of enumeration, counting each item with correct one-to-one correspondence. And lastly, because he rolled 6, Brandon moves his marker 6 spaces on the game board. Well, again, there's a large set of spaces on the game board. He has to remember 6 in his head, count out the 6, and know when to stop. So that'd be an example of set production. So with all these skills, these are things that there are different activities and types of instruction that encourages students to grow in all these areas as young learners. And there's a trajectory for which that occurs, typically in learners, and many curricula kind of follow this. Van de Waal in the book uses a little different words than Arthur Baruti did, but we can see here kind of a learning trajectory for counting, and the big idea being that students grow in their counting skills as exposed and practice with these skills in kind of this progressive order. According to Van de Waal, he talks about a pre-counter being someone who starts just being able to rattle off some of the number names, but may not have any idea what they mean and not being able to get that correctly. I'll show you a video of that in a second. A reciter is someone who is able to have that oral counting sequence somewhat correctly and now can just know that sequence out loud and say that out loud. A corresponder, again, is someone that can start to count one-to-one correspondence in a set pile of being able to attach one number name to one object. A counter being someone then who adds in that cardinality principle and can do it effectively and knows the last number said. Last number said represents the whole set. A producer is a set producer, and then kind of doing both, counter and producer, and then working backwards, being able to count backwards, starting at like 10 and going down to 1, or counting from any number, starting at the number 20 and counting up. And lastly, skip counting, starting at the number, skip counting by 3s or 5s or 10s. And it's kind of interesting. This video is going to be fairly short in terms of counting, but just know that there's an entire body of research around the development of these skills in children or learners that are at that level. So let's take a look at a quick video or two of some of these. And let's begin with kind of a cute little video that was popular on Facebook. And let's listen to this little girl as she is beginning her counting education.
No, 1, 2, 3, 4.
No, it's 1, 2, 3, 4, 5.
No, that's 1, 2, 3, 5.
No.
So very cute, but obviously we see here this girl is Van de Walle would say is a reciter. She's starting to get the idea of these number names down, but definitely doesn't have the she's a pre-counter. She doesn't quite have the order set, and it's kind of funny, you know, when you think about it, these number names are just syllables. That's all they are for a young learner. You know, it might as well be Abba Duba Blocka for blah blah, you know. But students are just memorizing this sequence of sounds, young learners, this sequence of sounds as they hear it from older people. In fact, when you hear 1, 2, 3, 4, 5, really, I mean, is that one word or one long word? It's really, again, just this idea of beginning of being a pre-counter is just getting used to these oral names to go through. So here we see a next video, a student that is a little bit further along. And let's take a look at his notion of oral counting as he is working on being a reciter. Let's take a look at and listen to him.
Start at the number 1 and count as high as you can.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22,
Oh my.
40, 50, 60, 70, 80, 90, 20.
Great. So here we see this boy is definitely along his way to be a reciter in his oral counting skills. In fact, he was correct all the way to 12. I think he skipped 13, made it to around 20, and then started skip counting and ended back at 20. But we just get the idea that it's a developmental skill. You know, we'll see at certain ages or grade levels, the idea of being able to oral count to a certain number becomes a goal, and get exposure to how this number naming works as it goes on. And it's just a development over time. So let's take a look at another one of a boy that's a little bit older here. And let's take a look at Jonathan here and where he's at in his trajectory.
Understand what you know about math. So what I'd like you to do first is take this cup of tiles and just spread them out on the table in front of you. And then I'd like you to do is arrange them so they're into groups of 10. And I'd like you to count out loud so I can hear what's going on in your head.
1, 2, 3, 4.
You don't have to worry about them. You don't have to worry.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That's great. And you have enough to make another group of 10?
Great. And right there we saw Jonathan did an example of set production, correct? He had that number 10 in his head, and he counted out 10 and stopped and was able to successfully produce a smaller set from a larger set.
10?
Yeah.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And so you have 2 groups of 10. How many extra tiles do you have?
4.
4. Do you know how many tiles there are altogether?
I'll count them.
What were you starting to do there, though?
Okay.
You can do it out loud so I can hear it.
10, 20. 21, 22, 23, 24.
24. Can you write that number 24?
Interesting. So here we just see an example where when he first struggled, he wanted to go back to just counting them all one by one, you know, doing enumeration. But she encouraged him to keep with his strategy, and he did 2 things there. First, he used some skip counting, correct? He knew those were piles of 10, so he was able to skip count 10, 20. And once he got to 20, he was able to count on from 20, count on from that number. 21, 22, 23, 24. So again, in that video, we see several different counting skills, and the boys practicing and learning those types of skills through some conversation and activities here. So how does this relate to the Common Core standards and what we see is expected of students in U.S. schools? Well, let's take a look. These standards here are from kindergarten, and these are not all of the kindergarten standards. This is just one small piece of them. But here we see a set of standards under the domain counting and cardinality. And when we look at it, we can see a lot of connections back to those counting skills that we just learned about. For example, at the top, it says count to 100 by ones and by tens. That's oral counting. That's also some skip counting. We see count forward beginning from a given number with the known sequence, so counting on from any number. Down below in the middle section, it says like understand the relationship between number and quantities. When we look at it, like 4a says when counting objects, say the number names in the standard order, pairing each object with one and only one number, and each number name with one and only one object. So again, that is this idea of being able to be a one-to-one correspondence, attaching one number name to one object. B says understand the last number name said tells the number of objects counted. Well, what was that called again? That was cardinality. And, part C, understand that each successive number name refers to a quantity that's one larger. Again, some number comparison type things going back to Broody. So, all of these here are just different skills. And lastly, with number 5, for example, it says, count to answer how many. Questions about as many as 20 things arranged in a line or an array or a circle, or as many 10 things scattered. And then it says, given a number from 1 to 20, count out that many objects. And there we see that set production. Just want to make that connection as teachers and just to understand some of the language of the standards. We see how some of the different research and knowledge developed works its way into the standards here that kindergartners are aimed for. So when doing this, one thing that comes up a lot with young learners is the idea of building number sense. And we hear that a lot. And what do you think that means? To build a child, to help develop a child's number sense. It's one of the titles of the chapter we're looking at in the Vanderwall book, and something you hear a lot in early elementary education. Well, let's take a look at some examples. There's not just one definition, but in Vanderwall's text, he quotes Howden, who says that number sense is a good intuition about numbers and their relationship. It develops gradually as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. So interesting, good intuition about numbers and their relationships. Involves exploring and visualizing, relating. Okay, let's take a look at one more. So this one is from the National Council of Teachers of Mathematics. As students work with numbers, they gradually develop flexibility in thinking about numbers, which is a hallmark of number sense. Number sense develops as students understand the size of numbers, develop multiple ways of thinking about and representing numbers, and use numbers as reference and develop accurate perceptions about the effects of operations on numbers. So interesting. I like this top part, flexibility in thinking about numbers, multiple ways of thinking about and representing numbers. Well, let's take a look at that. So what would that mean if we take a number like the number 8 and say that someone, a learner has strong number sense and wondering what they could say or show about the number 8. Well, let's think about it. Well, first of all, in terms of visualizing, they might be able to see 8 in different ways. For example, maybe they see a group of 4 objects, another group of 4 objects, and can count and represent that would be the number 8. Maybe they can see it as a group of 5 objects and 3 more objects. Maybe they realize there's lots of ways to make 8. For example, 1 and 7 make 8, or 6 and 2 make 8, or 4 and 4 make 8. That 8 can be broken down, and often we see that 8, an important thing might be benchmarking. For example, they might know that, 8, I know that's 3 more than 5. That would be an important benchmark to 5. Or maybe someone could say, I know that's 2 less than 10. Oh, that's good too. Being able to benchmark a number, anchor it to like a 5 or 10 would be important. But they can break it down, they can see it, they can recognize it, decompose it, relate it to other numbers. And all those are types of things we would expect to see if a child has a strong number sense. Flexibility in thinking about number. When we say number sense, let's break it down and think about some different components that involved in that. One of them is notions of quantity, being able to see how many are in a set. And one notion is being able to do that without counting, called subitizing, and we're going to look at that in a second. Number sense involves the counting we just talked about, being flexible, being able to count on from a certain number, count backwards, skip count, even skip count from a different number. We see it being more or less or same relationships, students being able to see different objects and piles, being able to determine in different ways what's more or less, how many more, how many less, when are things the same, is some common types of language you see around number sense components. We see students being able to develop relationships, like I said with the number 8. They could benchmark the number 8 to know how far it is from 5 or 10. They realize 8 can be broken down into many different parts, like 5 and 3 and 6 and 2. And then we see them being able to do the same type of thing with numbers in the teens and up to 20. For example, the number 13, well, that's 10 and 3 more. Or maybe that's, that's 6 and 6 and 1 more. Being able to decompose and look at those numbers in different ways. So these skills are some of the types of things we see when we talk about number sense. And let's take a look at a couple of these a little more in depth. So let's start with that notions of quantity, or subitizing, in the beginning here. So the word subitizing is one that became more popularized when the Common Core came out, and basically it means to determine the number of objects in a group without counting them, which we can think about for us as maybe like when you roll a dice. When you roll a dice, do you actually count the number of pips on the dice, or do you just know that it's 5? I just know that it's 6. Well, for most of us, we just look at it and we know, well, that's 5, that's 4. Because we see that number, that pattern of dots, and that corresponds to a quantity in our head. We know them without having to count one by one. And this skill called subitizing can be a fun skill to work on with young learners, because it encourages flexible ways of thinking about numbers. For example, I'm going to flash a little picture of dots here, and I want you to figure out how many they are, and I want you to think about how many you saw and how you saw them. So you ready? Well, if you had a partner, I'd encourage you to turn to your partner and talk to the partner is, what did you see? How many dots were there? What pattern did you see? And if we were in class, I would pull this back up and we could talk about it. What I might expect to hear is some people said, well, I saw 7. I saw that there was kind of a group of 6 that was diagonal, and then there was kind of 1 above and to the right. And that would be fine. But you also may see, I saw 7, but I saw it as kind of there was 3 groups of 2, kind of the top 2, then the next 2, and the bottom 1. So I saw it as kind of 3 groups of 2 and 1 below. Great. And as a teacher, I might write on the board 2 plus 2 plus 2 plus 1 equals 7. And from the first thing I said, I might write 6 plus 1 equals 7. And other people may have seen, I saw kind of a group of 5 up top with 2 and 3, and then another 2. Oh, cool. So you saw it as 2 plus 3 plus 2. And the idea here is being able to start looking at and just being able to, again, look at a group, break it into parts, and do that in a way of not counting one by one. And that was the purpose of the flash. So you don't have time to count it one by one. So let's try it again. I'm going to do one more here. And I'm going to flash it fairly quickly. So you ready? So what did you see? How many did you see? What pattern? Again, if you had a partner, I'd have you turn to your partner and talk. And then we put this back up and we could talk about it. Maybe people realize, I realized that we look at it, I saw 8, and we could, as a teacher, we could talk about it and circle things. Maybe someone saw it as, I saw 3 on the top, 3 on the bottom, and 2 in the middle. Great, so 3 plus 3 plus 2 equals 8. And maybe someone else would say, I saw it as 9, like I saw it as a full group of 3 groups of 3, but then I took away the 1 in the middle. 9 minus 1 equals 8. And subitizing is just a notion of working on a skill, being able to see quantity, to notice patterns, and break down things in kind of unique, and flexible ways. And there's lots of ways to go about subitizing and have students talk about how many they see and how they see it and see it in groups. These plates are an example from Walle of many different activities you could use, having students talk about how they see it, compare things, find plates that have a total of 8, find plates that have a total of 10, and just talk about, just again, number and quantity. I want to take a look at a quick, and so in doing that, another number sense component is the idea of anchoring or benchmarking to 5 and 10. Why does that mean? It means, again, with the number 8, we knew that there was 3 more than 5 and 2 less than 10. And this becomes important, and we have some ways of helping working on that skill. Often one common tool is called a 5 frame and a 10 frame. A 5 frame up top, I need to exit out of my large screen here. There we go. So a 5 frame up top is a way of just working on anchoring things to 5. So for example, If I was looking at the number 3, I could put it in here and realize that, again, 3 is, of course, less than 5, but I would need 2 more to make 5. So 3 is 2 less than 5, or I might say 3 and 2 more would equal 5. And I can look at numbers that are even greater than 5, like 6, and realize, oh, 6 is a group of 5 and 1 more. The frame, as we count and pull things in there and look at numbers, it helps us see a number in terms of 5. Again, going back to number 8 where we started, if I have 8 items, I could see a group of 5 and 3 more, and it helps me to be flexible in thinking about 8. And the 10 frame is definitely a more commonly used tool, just because we're in a base 10 system. And, if we look at things in the 10 frame, again, it's just a matter of helping students to see things in terms of 10. So if I go back and look at maybe 7, I could realize that 7 is 3 less than 10, or 7 plus 3 more would equal 10, and learning my combinations to 10. And again, we can look at just lots of different ways to see and make 10. And even here, if we look at things that are teen numbers, if we put them into the 10 frame, again, we can start to see the teen numbers as a group of 10 and some more. So in this case, if I was trying to count these using a 10 frame, I might fill my 10 frame first, and being able to use that 10 to say 10, 11, 12, 13, 14. And I can use it to count on as well from 10. So it's just a nice visual frame to help us see things in terms of 5s and 10s. Now, the 10 frame can be used in lots of ways. And I wanted to show a quick video of a teacher using it to help students see numbers while subitizing, kind of bringing these two things together. And it's a short video, but I think it's helpful to see what it looks like in classroom action. So I'm going to play this short video here.
My name is Stephanie Latimer, and today's lesson is Quick Images with my kindergartners. Quick Images is a very fast activity to show different combinations of numbers. And today's lesson was working on combinations to 8. Today I have 3 images for you, and I'm going to show them to you really quickly. You're going to give me a thumb right here if you have an idea how many you saw, and then I might ask you how you saw it. Are you ready? Here we go. The first time I show one of the images, I usually do about 3 seconds. A lot of my kids will count, and I don't want them to really count. I want them to see groups. I'm looking for thumbs. JT?
8.
8. Looking for thumbs. Isaiah?
8.
Devin?
8.
Michelle?
8.
Cameron?
8.
Dariana?
8.
Okay, I'm hearing a lot of 8s. I'm going to show you again, and it's okay if you need to revise your answer or if you have the same answer. Are you ready? Okay, so one more time. Here we go.
1, 2, 3, 4.
I was showing images up on the screen from the document camera, and that just was too much for them. Magnets on the 10 frame on a whiteboard. That was easiest for me. Courtney.
8.
8. Jaden.
8.
Mari.
7.
7. Laura Jean.
8.
8. Michelle.
8.
So you saw 8. Can you tell me how you saw 8? I'm going to put it up again so you can see it.
There's 5 on the top and 3 on the bottom.
So you said there's 5 on the top and 3 on the bottom. Can someone tell me what Michelle just said? Courtney, what did Michelle just say?
Except 5 on the top and 3 on the bottom.
5 on the top and 3 on the bottom. Did anyone else see it that way? Can you do this if you saw 5 on the top and 3 on the bottom? Okay, we're going to do another one. Are you ready for it?
How can be 8?
You're right, Cavell. Did you hear him?
Yeah.
He said it's still going to be 8. So now you know how many it is, right?
Yeah.
How many is it going to be? It's going to be 8. So I don't want to know anymore how many there are. I want to know how you see them. Are you ready? Okay. So you're not telling me how many anymore. You're telling me how you saw them. Cavell, can you tell me how you saw them?
I saw 2 on the bottom and 1 at the top and 4 right there and 1 right there.
Okay, so you're saying 2 and 1 and then 4 and 1. Okay. Someone see it a different way? Anyone see it a different way? Jalen, can you tell me how you saw it?
There's 4 on the bottom and 4 on the top.
Oh, so you're looking at the bottom here like this and the top here like this. Can someone tell me what Jalen just said, Laura Jean? What did he say?
He just said that there's 4 on the top and 4 on the bottom.
4 on the top, 4 on the bottom. Anyone else see it that way? But I think the most valuable piece this year for my kids has been just seeing combinations, that numbers can be in so many different kinds of combinations. So we started with 5 and just seeing, okay, there's 5, so 5 and 0. Or looking at it in another combination, well, there's 4 and 1, or 1 and 4. And they're really fluent with understanding that 4 and 1 can be 5, 1 and 4 can be 5, just that 5 is made up of all of these numbers. But I think I see some hands of a different way. Isaiah, did you see it a different way?
I counted by 2s.
Oh, you counted by 2s. Can you come up and do that for me real quick so we know what you mean?
Like 2, 4, 6, 8.
Oh, that's a quick way to count. I like that. Okay. Something that my class has been working on specifically is just having conversations around math. Augustine, I see a lot of people doing this. You saw it the same way. Caleb, can you tell me? So instead of just giving an answer, which I've told my kids a lot, like, I don't want to know your answer. I want to know how you figured it out or how you know.
There's 5 on the top and 3 on the bottom. And that's the same way as the first one, but there's 5 on right there and there's 1, 2, 3 right there.
So you're saying this is the same as the first image that we looked at. 5 and 3, 5 on the top and 3 on the bottom. Oh, I like how you made that connection. Nice job. To wrap up quick images, I always just kind of state what the purpose was for the day. So today, the purpose was different combinations to 8. So how many are here again? 8. And we saw 8 today in a lot of different ways. We saw 8 like 5 and 3, and we saw 8. Isaiah counted 2, 4, 6, 8. Lots of 2s, and we saw 8, 4, and 4. So we saw 8 lots of different ways today. Nice job. Quick images for us is a good example of what they mean in the Common Core by subitizing images or being able to sort images of things up to 10 in any kind of configuration.
All right, so good. So we see in that video just several things with subitizing, developing number sense, flexibility in thinking about numbers, having students be communicators, and the use of a 10 frame. Now the 10 frame wasn't being used to benchmark numbers to 10, but still is used as a tool to kind of see numbers in an organized way, and then it becomes a tool that will be used to see combinations of 10, shortly in these kids' trajectory here. So let's look at a couple other quick activities that just examples. There's lots in the course textbook and lots online. Let's see some examples of some things that can help students become flexible in their number sense. And we're just going to take a look at 4 kind of quick things that many are in the book, and there's a large variety of types of things to look at. So one in the book that talks about is a little game called number sandwiches, and there's number cards. These would be cut out onto little pieces of cardstock, and there's a lot of things you could do with these. But one fun game with number sandwiches is kids are given a certain number, for example, a number 9, and they need to make a number sandwich, meaning they have to find 2 pieces of bread that total to 9. And so with all these cards spread on the table, they may have to look for, maybe they grab one that has a group of 4, and they have to be able to count on or do some type of thinking to realize they need to find a piece of bread with the number 5, and they put those 2 together and make a sandwich, usually with the dots facing out, and put it off to the side as a group of 9. And maybe working with a partner, and each partner is trying to find different sandwiches that make 9. And then there's an interesting second step to the game, which is nice, is a partner shows the other partner the top piece of their bread, their sandwich, like a 4, and the other partner has to try and reason what the bottom piece of bread is. So if the top partner sees 4, they have to realize how many more to get to 9. And again, this is where some skills happen, for example, like counting on. Maybe they learn a strategy of saying, well, if there's 4 on the top, then they could use their fingers. Then I would need 5, 6, 7, 8, 9. And with their fingers, knowing that there would be 5 more to get to 9, and they can flip it over and see if the other side of the bread is 9. So here again, they get notions of quantity, being able to start to see these dots and get notions of quantity, and also in terms of flexible counting, to think about counting on, but also part whole relationships. Like a 9 is made up of 4 and 5, or 6 and 3, or 8 and 1 along the way. So with that, we there's several different things happening with number sandwiches. Another one, just very simple, is the idea of looking at different types of skip counting. And dice and cards and things like that can be nice as well. So here's a little game where students roll 2 dice, and maybe they roll a 6 and a 5. And this is for students working on 2-digit numbers. And they get the number 65. And maybe they have to write down a number that's 1 more or 1 less than 65 as they go through. Maybe they have to write the numbers that are 10 more and 10 less than 65. Or 5 more and 5 less than 65. And it's just a quick activity that helps students start with a number, being able to count on both forwards and backwards. And just kind of a sample again of ways to encourage students to start thinking about numbers, counting, and strategies to go through, looking for patterns. Another one is called the caterpillar number sort, and the caterpillar number sort is just an example of kind of another matching activity. And this activity, there's lots of different pieces of caterpillars, and there's different types of pieces. Like in the top left, we see those use of 10 frames again. We see things in groups of 10. We see just the regular written number down below. We see tally marks in groups of 5. And then we also see base 10 blocks. The goal here would be for students to basically work with these numbers and be able to create caterpillars like this one that can find the matching pieces that go together and see it in different ways. How would we see 50? Well, with base 10 blocks, I see it like that. It's 5 groups of 10. With the 10 frames, I see it as, again, I can see all 50 things. When I group them in 10s, I can see there's 5 groups of 10 that way too. And with the tally marks in groups of 5, it's actually 10 groups of 5, skip counting by 5s. And so this is just different ways of helping students be flexible and seeing how they see numbers and different ways to go through. Another activity from the book is called Line Them Up, and it became popular a few years ago as far as clothesline math. And there's lots of ways to have fun here. But you see in the picture, there's actually like a string going across, and then tenths, little pieces of paper folded to make a tent. And students can work on this type of number line to order numbers from least to greatest, to place numbers in the correct spot in kind of a movable number line. And for example, if in the book it talks about, for example, giving students a range. For example, I'm going to go ahead and go back here. So for example, let's say as a teacher we began with the number 0 up to the number 30, and that was our number line. We put those tenths on the string or the number line there. You might ask a student to take the card 10 and wonder, where is that going to go on the number line? And maybe they think, well, it's going to be between them. It's going to be, over here. And, just questions. We just talk about it. Okay, interesting. So yes, 10 is between 0 and 30. Is 10 closer to 30 or closer to 0? How do we know? We have conversations, and maybe we realize that 10 is actually closer to 0 than 30, and maybe it's less than half of 30, so I don't know, maybe somewhere around there. And we might have a student to think about, where does 12 go? Maybe they say 12 is going to be between 10 and 30. Great. Now let's think, is it closer to the 10 or closer to the 30? Well, I think it's closer to 10. We might talk about, well, how much more than 10 is it? Can we count from 10 to see how much more it is? 10, 11, 12. Oh, it's 2 more than 10. And just the idea, again, of having conversations around numbers, being able to have students think about where numbers would go in relation to each other, how many more, how many less. And it's just an interesting way to get students to think about numbers. The thing about this can be used for a lot of things, including fractions and decimals and percents, and helping build that conceptual understanding of number. So, given the purpose of our class, we're not spending too long on early childhood number development, but I just want to give you a taste of some of what some big ideas are in kindergarten and some younger grades to think about counting and number sense and development. And to end back with this, I'm going to end the video here just with this definition again of number sense. A good intuition about numbers and their relationships develops gradually as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. And the big idea here is by building a solid number sense now, it's going to pay dividends later. And we'll see as we get to more computations and thinking of multiplication and division and fractions. If we can take numbers apart, see them in many ways, know how to benchmark them, it's going to be amazing how those skills will pay huge dividends later as students continue to progress through the curriculum. So that's it for today. Hopefully you enjoyed learning about number sense, and talk to you soon.